இந்த வீடியோட தமிழ் வெர்ஷன் கமெண்ட்ல பின் பண்ணிருக்கேன். Make use of it. Hi everyone, welcome to this video on Mosfet symbols. If you are learning electronics, understanding these symbols is super important for reading circuit diagrams. Here is what we are going to learn today. We will start with basic Mosfet structure. Following that, we will dive into Mosfet symbol components such as arrow direction and channel line. Then we will compare N-channel versus P-channel Mosfets. In that, we will be highlighting their differences in symbols and operation. Then we will look at enhancement mode versus depletion mode and how their symbols differ. Finally, we will see some easy tips to read Mosfet symbols in circuit diagrams. Let's get started. Mosfet stands for metal oxide semiconductor field effect transistor. It is a key component in modern electronics used for switching and amplification. Understanding their schematic symbol is crucial for reading and designing electronic circuits. It has three terminals, which are source, drain and gate. In source, charge carriers enters the device. In drain, the charge carriers exit. Gate terminal controls the flow between source and drain. Optionally, there is a body terminal called as substrate, which is often connected to source. Now let's understand the components of Mosfet symbol. First, gate terminal. The gate is the line separated from the channel. It is the control terminal that manages whether current flows or not. The gate line is perpendicular to the channel, which is sitting between drain and source terminal. Next, channel line. The channel is the path where current flows. It actually indicates whether the MOSFET is in depletion mode or enhancement mode. Dashed or broken line indicates that the MOSFET is in enhancement mode. In this mode, the MOSFET is off by default, but when you apply voltage to the gate, it turns on. Solid line indicates that the MOSFET is in depletion mode. In this mode, the MOSFET is normally on without any voltage applied to the gate. Next, arrow. Arrow shows the direction of current flow and type of channel. For N-channel MOSFET, the arrow points into the body. For P-channel MOSFET, the arrow points away from the body. Look at the diagram. The arrow comes from the body, but sometimes we say arrow on the source because source and body are usually tied together in the circuit. Remember, arrow shows the type of MOSFET, not the actual current direction. Next, the body connection. The body or substrate is usually connected to the source. It might be shown in the diagram or sometimes it is left out for simplicity. Next, N-channel MOSFET symbol and P-channel MOSFET symbol. In N-channel MOSFET, electrons are main carriers. They are faster than holes. The MOSFET turns on when gate voltage is positive. The arrow on the symbol points in, which means electrons are entering the channel. Think N pulls in, so NMOS is pulling in electrons. In P-channel MOSFET, holes are the main carriers. They are slower than electrons. The MOSFET turns on when the gate voltage is negative. The arrow on the symbol points out, which shows that holes are leaving the channel. So the current is going away from the channel. Think of P for pushes out. So PMOS means pushing out holes. Just look at the arrow direction. Arrow pointing in is N-channel. Arrow pointing out is P-channel. Next, enhancement mode versus depletion mode. MOSFET is classified into two types based on type of operation, which are enhancement mode MOSFET, in short E-MOSFET, and depletion mode MOSFET, in short D-MOSFET. And these two types are further classified based on the type of semiconductor material used for their construction, so that it results in four distinct types of MOSFET, which are N-channel enhancement mode MOSFET, P-channel enhancement mode MOSFET, N-channel depletion mode MOSFET, and P-channel depletion mode MOSFET. Now let's see how their symbols differ. Before that, let's understand the basic difference. E-MOSFET is a type of transistor which stays off when there is no voltage at the gate. That means by default, it doesn't allow current to flow from source to drain. To turn it on, we must apply voltage to the gate. For N-channel E-MOSFET, we give positive voltage. For P-channel E-MOSFET, we give negative voltage. So only then a conductive channel is formed between source and drain, and current can flow. E-MOSFETs are commonly used in digital electronics like logic gates, microprocessors, and memory chips because they stay off until needed. E-MOSFET are great for switching applications. The symbol for this MOSFET has dashed line, meaning the channel appears only when gate voltage is applied. Now let's see the symbol. Let's start with Shorthand notation of N MOSFET and P MOSFET in enhancement mode. You can see two symbols, NMOS on left and PMOS on right. First, let's talk about NMOS symbol. It has three terminals, gate, drain and source. In this symbol, there is a straight line in the middle, that's the channel. And the thick bar on the side is gate control. Now look at the PMOS symbol. You'll notice there is a small circle on gate terminal. The small circle is like a digital NOT symbol, which means the behavior is inverted compared to NMOS. Now let's understand DMOSFET. It is a type of transistor which is normally on when the gate voltage is 0. That means even if you don't give any voltage to the gate, current can flow from drain to source. To turn off the device, you apply a voltage to the gate that removes the charge carriers in the channel. So inside the MOSFET, there is a channel where current flows. It is like a road where electrons or holes travel. In DMOSFET, the road is already open, so current always flows unless you do something. Now if you want to stop the current, that is to turn off the MOSFET, you have to block the road. Now how do you block it? To do that, give a voltage at the gate terminal, and that voltage pushes away the electrons or holes. So the road becomes empty or blocked. This is called depleting the charge carriers. You are just removing the people from the road. In short, to turn off DMOSFET, we give a gate voltage that clears out the current path, so current can't flow anymore. Here, the channel is already formed inside the MOSFET. That's why it can conduct even when gate voltage is 0. To turn it off N-channel DMOSFET, we apply negative gate voltage. To turn it off P-channel DMOSFET, we apply positive gate voltage. DMOSFETs are used in analog circuits and are often used as load devices in digital ICs. The symbol for this MOSFET has a solid channel line, showing that the channel is always there. In circuit symbol, the only difference between DMOSFET and E MOSFET is the line inside the channel. In DMOSFET, solid line, meaning the channel already exists. In E MOSFET, dashed line, meaning the channel appears only when gate voltage is applied. Now look at the shorthand notation for N MOSFET and P MOSFET in depletion mode. The depletion mode MOSFET conducts by default even without gate voltage. So the channel is shown thicker in diagrams, which indicate its natural conductivity. In shorthand notations, the arrows are not shown. These are simplified versions commonly used in circuit diagrams. Let's again start with N MOSFET and P MOSFET in enhancement mode. First, look at the N MOSFET in enhancement mode. Notice the dashed line represents the channel. Dashed line means it is an enhancement mode device. The arrow points inwards towards the channel from the substrate. Here the arrow direction follows PN junction physics, meaning the arrow points from P to N just like a diode. In an NMOS, we have P-type substrate and N-type channel. So naturally the arrow points from substrate P to channel N. Now look at P MOSFET in enhancement mode. Again, we see the dashed line for enhancement mode channel. The arrow points outward from the channel to substrate. In PMOS, we have P-type channel and N-type substrate. So the arrow points from channel P to substrate N. And why dashed line for enhancement mode? Think it is an incomplete or potential channel, meaning the channel does not naturally exist, so it need to be enhanced or created by applying gate voltage. Again, let's see N MOSFET and P MOSFET in depletion mode. First, N MOSFET in depletion mode. Here the channel is represented by a solid line. The arrow still points inward, same as P to N direction as before. And all other elements remains the same as enhancement NMOS. Now P MOSFET in depletion mode. Here the channel line is solid. Arrow points outward. Same like P to N direction as before. And all other elements match enhancement PMOS. Here why solid lines for depletion mode? This represents a complete or existing channel. The channel naturally exists without any gate voltage. It must be depleted to turn off the device. Deplete means to remove or stop. Now think of channel line as a water flow. Dashed line means enhancement mode. No natural flow, it need to be enhanced to create a flow. Solid line means depletion mode. Here natural flow already exists. It need to be depleted to stop flow. In these symbols, we are explicitly showing substrate as a separate from source. In practical circuits, they are often connected. So that's why the shorter notations omits the substrate. Always remember the arrow points from P to N just like a diode. So this helps you instantly to identify whether you are looking for NMOS or PMOS. For enhancement mode N MOSFET, conventional current flow from drain to source. Electron flow from source to drain. For enhancement mode P MOSFET, conventional current flow from drain to source. Holes move from source to drain. For depletion mode N MOSFET, conventional current flow from drain to source. Electrons move from source to drain. For depletion mode P MOSFET, conventional current flow from drain to source. Holes move from source to drain. Conventional current is just an agreed upon direction. See, what does current mean? It is electricity flowing, like water flowing in a pipe. Long ago, scientists thought current flows from positive to negative. So everyone started using that direction even though it is wrong. Later we discovered electrons which carry electricity actually move from negative to positive. After that it was too late to change all the math and books. So everyone agreed to the original direction that currents flows from positive to negative. And this is called conventional current. So real electrons go on one way, but we draw the current on other way. Now these symbols represents the IEEE standard for MOSFETs where substrate is connected to the source. So only 3 terminals are shown, which are gate, drain and source. First symbol is enhancement mode NMOS. It has a dashed line meaning enhancement type, normally off. The arrow points inward towards the source. So NMOS. The second symbol is depletion mode NMOS. It has solid line meaning depletion type. It is normally on. The arrow points inward. So NMOS. Third symbol is enhancement mode PMOS. It has dashed line meaning enhancement type. Arrow points outwards. So PMOS. Fourth symbol is depletion mode PMOS. It has solid line, so depletion type. Arrow points outward. So PMOS. Here the arrow on the source leg shows the type of a device, not electron flow. It is not like a diode, it's more like a label. For NMOS, conventional current flows from drain to source. For PMOS, conventional current flows from source to drain. Maybe it can look confusing at first, but once you understand the line and arrow, it is easy. And here are some tips for reading MOSFET symbols in schematics. First, identify terminals by arrow and line style. The gate is always shown as a line perpendicular to the channel. The source terminal is typically identified by the arrow, or where the arrow points. The drain is opposite side from the source. Next, look channel line type to determine mode. Broken or dashed line means enhancement mode, normally off. Solid line means depletion mode, normally on. After that, arrow direction indicates channel polarity. Arrow pointing in means N channel, that is NMOS. Arrow pointing outward means P channel, that is PMOS. In IEEE symbols, arrow on source leg shows current flow direction. And next, body connection assumptions. In many schematics, the body or substrate connection is not explicitly shown. When it is not shown, assume it is connected to source. If body is shown separately, note any special connections affect device behavior. Next, remember current direction. For NMOS, current flows from drain to source, like water draining down. For PMOS, current flows from source to drain. That is, source provides the current. And final set of tips is always refer to the schematic legends and datasheets.